Good morning, class. We are looking at section 8.8, vectors. We have covered a big chunk of this. So let's quickly recap what we have done, and we are going to move on. So we covered polar equations and graphs, complex plane, De Moivre's theorem, and now the vectors. Basic trig identities, more formulas and identities, polar coordinates and the relationship between them and rectangular coordinates. Here, x and y versus r and theta. X is r cosine theta and y is r sine theta. X and y is unique, r and theta are not. We can represent them in infinitely many different ways by adding 2k pi to theta or changing r to negative and adding odd multiples of pi. Various graphs were discussed here. Tan equals alpha is a line, r equals a is a circle. R cosine theta equals a is a vertical line, r sine theta equals b is a horizontal line. R equals plus minus 2a cosine theta, r equals plus minus 2a sine theta represents a circle. R equals a represents a circle. Complex plane. The x-axis is considered to be the real axis. The y-axis is the imaginary axis. And the magnitude OZ, or the magnitude of z, or r, is square root of x squared plus y squared. And we can find theta as usual. Tan theta is pi over x. We have to consider the proper quadrant. And a number z, which is x plus yi, or you recall it as a plus bi, it's a complex number where x is the real part, y is the imaginary part, and we can represent it as x being r cosine theta, y being r sine theta, or z is r cis theta for short, because it is r cosine theta plus I r sine theta, where I, by definition, is square root of negative 1. In the case of multiplication, when we multiply two complex numbers, we multiply their magnitudes and then we add up the arguments. So cosine of theta 1 plus theta 2 plus I sine of theta 1 minus plus theta 2. When we divide them, we divide their magnitudes and we subtract their arguments. For De Moivre's theorem, when we want to raise a complex number to the nth power, we raise its magnitude to the nth power and we multiply its argument by n. When we want to take a root, we represent a function in the form of r cis theta. Then we take the nth root of r, which is the magnitude. We divide theta by n, or theta sub 0 by n, and then we add 2k pi, and we divide it by n. We let k be 0, 1, 2, all the way to n minus. That's how we find complex roots. So for any n larger than or equal to 2, there are n complex roots. Then we discussed vectors, the concept of a geometric vector, and the difference between vector and scalar. Vectors have magnitude and directions. The properties of addition and scalar product was discussed, very similar to real numbers. Adding vectors geometrically, the concept of opposite vectors, which gives rise to the difference. So V minus W means V plus the opposite or minus W. And we looked at some examples involving this concept. The magnitude of the vector is defined as the square root of a squared plus b squared, just like the magnitude that we saw for polar cases. Position vector, a vector with the initial and terminal points x sub 1 and y sub 1 being p, the initial point, q x sub 2 and y sub 2 will be the terminal point, then pq is x sub 2 minus x sub 1, comma y sub 2 minus y sub 1. So basically, we can move the vector such that the initial point is at the origin. Now it becomes known as a position vector, and this is the formula which will find the components A and B. In short, two vectors are equal if they have equal components. To find vector from its direction and magnitude, we use V equals the magnitude of V times cosine alpha I plus sine alpha j. That is the case here. Alpha is the angle that it makes with the positive side of the x-axis. We continue with the same thoughts here. Vector properties of addition and scalar products. In this case, we just added and subtracted vectors algebraically, just the way we would do with operations on real numbers. A unit vector in the direction of the vector v is defined as dividing the vector v by its magnitude. And when we do that, means we need to calculate the magnitude first, as we did in this example, and divide the vector by it. And the new vector, we have to check, we can check, by calculating the new magnitude, which must be 1. Now let's move on. So we did this, and we're going to go to the new example. So finding a vector from its direction and magnitude has been discussed, and we have it here. Let's look at this example. We want to find the direction angle of this vector v, which is negative 3i plus 3j. So it is a good practice to draw it first so we can see where it lands. As you can see, I negative 3, so 3 units to the left, 3 units up, so somewhere there. Tan of theta is 3 over negative 3, which makes it negative 1. And if you go with the calculator, it will give you a negative value because the tan inverse goes from minus pi over 2 to pi over 2. But we know the location. It is in the second quadrant, so it's negative 45 degrees. We add 180 and it becomes 135 degrees. So it's important to know this. If we use a calculator, it will give us minus 45 degrees. But we know it to be in the second quadrant. Find the vector v, whose magnitude is 9, and the angle it makes with the positive x-axis is alpha equals 225 degrees. So this is equal to 9. And so over here, we can replace this one with 9 and alpha with 225 degrees. So V, which is alpha I plus beta j or bj, or in this format, either one is fine. A is 9 cosine of 225 degrees, and the B is 9 sine of 225 degrees. And as you know, this puts us in the third quadrant where both sine and cosine are negative. I hope you realize that the reference angle, since we used alpha here, I'm going to write alpha sub r is 45 degrees. As you know, sine and cosine are square root of 2 over 2 in both cases. In the third quadrant, they're both negative. And so we get negative 9 square root of 2 over 2i minus 9 square root of 2 over 2j. Again, the reason being because this, when it's 45 degrees, cosine, sine, both of them are square root of 2 over 2. Third quadrant makes it negative. Resultant force, when we have force 1 F1, force 2 F2, and we want to add them up, we add them up the way we add vectors. For example, a plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. So let's draw a setting to see what's going on. So the plane is flying 200 miles per hour in this direction, north 55 degrees east. So that's the first part. The second part, the wind blowing from west to east, going this way. So from left to right. That's the wind. And here's the resultant we are looking for. So the true course is going in this direction, which means we need to find the following. We need to find this angle, and then we need to find the magnitude, and then we need to find this angle, and this is the angle that results in northeast, and this is 90 minus theta. So Again, what do we need to find? The magnitude of this vector. The direction of this vector is north, east. So we need this angle. What is this angle? 90 minus theta. And by the way, if this is 55 degrees, this one is 35. I want to make sure that we understand this one. Because 90 minus 55 gives us 35 degrees. So let's write what we have. Velocity relative to air, we call it V sub A. The magnitude is 200 miles per hour. That means this one. And the angle it makes with the positive side of the x-axis is 90 minus 55, and that gives us the 35 degrees. The wind going this way has the magnitude of 35 miles per hour, and it makes a 0 degree angle because it's going from west to east. So it makes a 0 degree angle with the positive side of the x-axis. So I'm going to call this theta sub A, right? And this one is theta sub W. All right, so let's calculate each one and let's add them up. Simply put, this V is the sum of VA and VW. So VA, using this formula, we're going to get to VA, V sub A, as well as V sub W. So V sub A, according to this formula, is 200 cosine of 35 degrees I plus sine 35 degrees J. At this point, you put it into a calculator, you approximate it, and this is what you get. So you need to put this into a calculator because it's not a common arc. For the wind, we do the same thing. It's 35 cosine of 0 degrees I plus sine of 0 degrees J. As you know, sine is 0. This one you don't need a calculator. This is 0. This is 1, so 35I. And the velocity relative to ground, we simply add them up according to this resultant force in red. So to add these two, we just add their components. We're going to add this one and this one, and this has nothing to be added to because the J component is 0 here. So add these two, 198.83I, and this one, there is no J component. So approximate the ground speed. Now we need the speed, which is the magnitude. So we want the magnitude for this, which is the square root of A squared plus B squared, which is the square root of this number 198.83 squared plus this number 114.72 squared. And again, you put it into a calculator and you approximate it to the nearest mile, and you end up with 230 miles per hour. It's a good practice to show the number with a bunch of decimals and then do the rounding to be on the safe side. You can calculate this one by finding the tangent, because the resultant force is this. So tangent is y over x, or the J component, 114.72 over the I component, 198.83. Using a calculator, roughly it gives us 30 degrees. We are interested in 90 minus that. So we are doing 230 miles per hour We are going northeast. What is 90 minus theta? 90 minus 30 is 60. So 230 miles per hour, north 60 degrees east. We want to find a scalar multiple. The magnitude of the vector v is given, w is given. So if we want 3 times v, simply put 3 times that. Which makes it minus 9, 12. Very straightforward when we do operations on vectors class. Very straightforward. Part B, 2 times v, 2 times this, minus 3 times w, 3 times this. So we distribute the 2, we get minus 6 and 8. Distribute the 3, we get minus 6 minus 15. These 2, they give us minus 6, minus 6. This is for the first component. 8 plus 15, the second one. And so we get minus 12, the vector with the I component minus 12, the J component 23. The magnitude is just simply square root of A squared plus B squared. For V, A is negative 3, B is 4. Obviously, by now we know it. This is 9, this is 16, so they add up to 25, and the square root of that is 5. A box that weighs 1,200 pounds is suspended by 2 cables as shown. Find the tension or the magnitude in each cable. So here's the box, here's the 2, and the 2 cables, and we want to calculate the tension, and the angles 45 degrees, 30 degrees. And so we draw what is called in physics free body diagram. Free body diagram gives us the forces, and it gives us a chance to calculate the resulting forces. Now, in order for this to suspend with no problem, then the sum of forces must be 0. This is equilibrium position. So the sum of all forces must be 0. That's in physics. So first and foremost, let's find out what each one is, starting with F1 is the magnitude of F1. That's what we are looking for, by the way. Now, this is 30 degrees, makes this one 150. So cosine of 150 plus sine of 150. F2, the magnitude of F2, and now the angle is 45 degrees, cosine of 45 plus sine of 45. And F3 is the weight that it weighs 1,200 pounds. So simply put, means minus 1,200 J. It's in the negative J direction, or you might say this is negative power 2, or this is 3 power 2. Either way, you can calculate this one. Cosine of 3 power 2 and sine of 3 power 2. Sine of 3 power 2 is negative 1. That's what we have. Now, the summation of f, this is the notation, the summation of f must be 0. And in order for that to be 0, all the components must add up to 0, meaning you calculate all the components in the I direction, you calculate the components in the j direction, and each one must be equal to 0. So let's put summation of f, which is f1 plus f2 plus f3. Now, when we go back here, remember 150 degrees, that means the reference arc is 30 degrees. Use a red one for that. Theta sub r is 30 degrees. So in the second quadrant, cosine is negative. So cosine of negative 30 degrees let me clean this up, minus square root of 3 times 2. This one is simply positive 1/2 because sine of 30 is 1/2. For 45 degrees, both of them are square root of 2 over 2. Therefore, we get this one. So let's quickly go over that, making sure we understand. So this one is the magnitude of f1 times cosine of 150, which is minus square root of 3 over 2, and then times sine, which is 1/2. And we have the I component and the j component. In this case, both of them are square root of 2 over 2. So square root of 2 over 2, magnitude of f2 times I, square root of 2 over 2, magnitude of 2 times j, and this one is minus 1200 j. It's been already done. So in order for this to be 0, each component must be 0, which means the I components, these two, must add up to 0. And the j component, so that's the I components, put these two together, they must add up to 0. And the j components, the rest of them, I'm going to put them in green, the rest of them must add up to 0, which means half of the magnitude of f1 j plus square root of 2 over 2, the magnitude of f2, and minus 1200 j, they must add up to 0. And this is a system to solve. I'm going to show you on the next page how to solve it. I'm going to give you the answer for now. And then I'm going to quickly go over that. It is a system of equations. It's really not too bad. It's not too difficult. So when we go through the process of a system, again, next page, I'll show you the system. We end up with f1 being 2400 divided by square root of 3 plus 1. We use a calculator, and it gives us roughly 878.5 pounds. This would be the tension here for the first cable. And for the second one, square root of 3 over 2 times 2400 over square root of 3 plus 1. Again, with a bunch of decimals, and then you round it accordingly. It's 1075.9 pounds. Now, how did we get this? We solved this system. So let me quickly show you how you solve this system. So we are done. I want to go over the elementary algebra behind this system, because the system may appear to be a little bit involved for some students. So we put these two together. I'm going to write these two. That's what we have. The very first thing, let's get rid of the fraction. So in both cases, we're going to multiply by 2. So if I multiply the first one by 2, the denominator goes away. If I multiply this one by 2, the same thing. And I'm going to move this one to the right. This becomes 2400. Minus 2400 goes to the right, becomes positive 2400. So again, first, we are going to get rid of the fractions. And then this one minus 1200, which becomes minus 2400, we move it to the right. Since we want to solve this, it is easy to solve it by the addition method. Notice these two are identical. So if I subtract one from the other, or simply I'm going to multiply one of them by negative, either this one or that one makes no difference. If I multiply this one by negative, this becomes minus, this becomes minus, this becomes minus. So I'm multiplying the second one by negative. And so these two cancel each other. Right? So we add up these two into minus the parentheses square root of 3 plus 1 times the magnitude of f of 1 equals negative 2400. So if we divide both sides by this number, so divide this number by this number, that gives you the answer. And a negative over negative makes it positive. That's why I'm going to put positive. At this point, square root of 3 is about 1.71. You use a calculator, you end up with the number that we had in the previous page, 878.5 pounds. Now we're going to go back to one of the original equations. The first one, this is the simplified version. So into this one, equation 1, I'm going to replace the magnitude of f of 1 and come up with the answer. To do that, I hope you realize this is the same. If you move it to the other side, you can write f2 is minus square root of 3f1 divided by square root of 2 minus over minus becomes positive. I hope you see it's a simple elementary algebra work here. So move this one to the other side and then divide by square root of 2. Now, whatever f1 is, square root of 3 over square root of 3 over square root of 2. And this is the exact answer, by the way. That's why I put that one, although you can use this one. And we have 1,075.9 pounds of force. Very straightforward class. Again, this is a system of equation that we solve here. A piano is being pushed up a ramp inclined at an angle of 20 degrees with a force magnitude of 300 pounds going this way. So we want to find its weight. So first and foremost, we need to understand that we are pushing it this way, parallel to this ramp, and the magnitude is 300 pounds. So the force this way is 300 pounds. The force this way is the weight, and the force this way, F sub 3, which is perpendicular to the ramp, is called the normal force in physics. So let's see what's given. Theta is 20 degrees. This is 20 degrees. This is the weight. Magnitude of F1 is the weight we are looking to find. F2 is 300 pounds, the magnitude. And F sub 3, the name is normal force. So this is 20 degrees, and so this is 20 degrees. BAC is given as 20 degrees, and we find this one to be 20 degrees as well. Why is that? Because the two triangles, this is one of them, and this is another one. When two sides are perpendicular, see, this side is perpendicular to this one. This side is perpendicular to this side. It makes the two angles equal. One easy way to prove it is this. If you look at this angle, let me show you, and I'm going to erase it then. If you look at this angle, this whole thing is 180 degrees. Then we have angle 1, which is 90 degrees, angle 2, and angle 3. Angle 3, with this one, they add up to 90 degrees. And because with this one, they add up to 90 degrees, then this becomes identical to that. So that's one way to prove it. I hope everybody can see that. So let me erase the mess. And so sine of 20 degrees, if you look at this, sine of this angle, 20 degrees, is the opposite. F2 over the hypotenuse. Hypotenuse is opposite the 90-degree angle, which makes it F1. So we are looking at this triangle, okay? And we know this to be 300. Therefore, the magnitude of F1, which represents the weight, is 300 divided by sine of 20 degrees. And we can use a calculator for that. And with an approximation, we get 877 pounds. Again, use a calculator, maybe put 1 or 2 decimals, and then do the round. Find a unit vector in the same direction for v equals 4i minus 3j. And the magnitude, as we mentioned, is the square root of a squared plus b squared. So the magnitude for this one would be the square root of 4 squared plus negative 3 quantity squared. So we have to calculate that. And as you know, again, this is 16, this is 9. They add up to 25, and the square root is 5. We've done it many times. So we found the magnitude, and all we have to do, divide the vector by this number. This would be the unit vector, which means the unit vector in the same direction is 4 over 5 times I minus 3 over 5 times j. And again, it's really a good practice to check. All we have to do, square this number, and they must add up to 1. This is 16 over 25. This is 9 over 25, which makes it 25 over 25. That's 1. And then when you take a square root of 1 is 1. So that is the proof. This is checking, everybody. And it can be easily done. A ball is thrown with an initial speed of 25 miles per hour in a direction that makes an angle of 30 degrees with the positive x-axis, horizontal. Find the components of the velocity vector, horizontal and vertical. And again, reminding everybody about the formula. V is the magnitude of V times cosine alpha I plus sine alpha J, and we are interested in finding their components. So here's how it looks like. We are going to make a 30-degree angle and have an initial speed of 25 miles per hour. So we write the magnitude is 25 miles, theta is 30 degrees, theta, alpha, you name it. Perhaps alpha, either way is fine. So, yeah, maybe you want to go with, not that it makes much of a difference, but you can say alpha if you want. And so using the formula, we plug in 25 times cosine of 30 degrees I plus sine 30 degrees J. Cosine is square root of 3 over 2 and sine is 1/2. Both are common arcs, so we know those values. So 25 square root of 3 over 2I plus 25 over 2J, and those are precise answers. So the horizontal component is 25 square root of 3 over 2. And the vertical is 25 over 2. Approximation 21.65 miles per hour in a horizontal direction. And the speed along the vertical direction is 12.5 miles per hour. And it looks like this, the final result. So 25 miles per hour, 30 degrees. This component is about 21.65. It's about 12.5, and this is how you write the V, the magnitude times the components. All right, we have one more question. Could somebody read this, please?
A Boeing 737 aircraft headed due south maintains a constant speed of 500 miles per hour. The jet stream is 80 miles per hour in the northeast direction. A, express the velocity VA of the 737 relative to air and the velocity VW of the jet stream in terms of I and J. B, find the velocity VG of the 737 related to ground. Part C, find the actual speed and direction of the 737 relative to the ground.
Excellent. So let's see what is given, and we're going to do part A on this page. So the Boeing headed due south at a constant speed of 500 miles per hour. The jet stream, the wind blowing 80 miles per hour in the northeast direction. So the magnitude of the velocity of the aircraft is 500 miles per hour, and the angle theta alpha, whatever you want to call it, is due south, makes it negative 90 degrees. For the wind, the magnitude 80 miles per hour. Northeast, that is 45 degrees. Theta is 45 degrees for the wind, or you can say theta sub W. So due south That's the aircraft, the wind, and here's the resultant vector. So the velocity of 737 relative to the air, we just follow this formula. The magnitude times cosine of alpha I plus sine alpha j. We want to write it in terms of its components. And the cosine of minus 90 degrees is 0. Sine of minus 90 degrees is negative 1. This is 0. This is negative 1. And so VA is minus 500J. We write the same thing for the wind. AD cosine of 45 degrees I plus sine 45 degrees J. And as you know, both of them are square root of 2 over 2. When you divide by 2, you get 40. So 4D squared of 2 times I plus J, or you can say 4D squared of I plus 4D squared of 2, 4D squared of 2I plus 4D squared of 2J. All right, so that's part A. We found both of them in terms of their components I and J. We're going to move on to part B. We're going to find the velocity V sub G of this 737 aircraft relative to the ground, which means we need to add the two. And I'm writing the information we calculated from the previous page. V sub A is minus 500J and V sub W is 4D squared of 2 times I plus J. We just add them up. So let's add them up component wise. And so this is 4D squared of 2I, and then we have 4D squared of 2J minus 500 times J. So we simply add them up. We write them with the components. And now we want to find the actual speed. Right here means the magnitude. So direction, that means we have to write this direction. So we want the magnitude using this. Then we find the direction according to this. So what is the direction? So I want to write what we are looking for. So we are looking for the information that we have here can help us calculate this angle. But it is going in the following direction, southeast, and this is the angle, 90 minus alpha. That's what we are looking for, 90 minus alpha. So again, the direction for V sub G. We know it's southeast, but we need this angle. So when we calculate this one, 90 minus that is what we are looking for. And the reason we can calculate this because we have the components. All right, so the magnitude, 4D squared of 2, quantity squared, and then 4D squared of 2 minus 500, quantity squared. Now this obviously use a calculator, you simplify, you use however many decimals they want. Normally they want 1 decimal. So this does have a couple of steps using a calculator ending up with 447 miles per hour. So we got this part, 447 miles per hour, we got the speed. Now, this angle, tan of this angle is the component J over the component I, their value. So 4d square root of 2 minus 500 over 4d square root of 2. That is the angle we're going to call alpha. And using a calculator and inverse function, alpha becomes negative 82.7. So this is negative 82.7. Remember, this whole thing is 90 degrees, right? So if you subtract 82.7, gives you this angle. And this angle is 90 minus 82.7, which is 7.3 degrees. Again, this angle, 7.3 degrees. Why is that? The entire angle of 90 degrees. Subtract 82.7 from it. So 90 minus 82.7 degrees give us this angle.